everybody doing? Hope that everyone's having a great week so far. Happy Thursday. We're a little bit earlier than normal this week. Got some other things going on, so we'll go ahead and get started this week. So what are we taking a look at? Well, we are going to be learning about horizon charts. So Luke Stanky's got a challenge for us, and I know he's usually his challenges are usually a little bit more involved, a little bit more in depth, and than some of the other challenges. Sometimes a little bit more technical, but the good thing is we've got lots of community resources that are going to be able to help us out in order to build this. So I did kind of break my my tradition. I have looked at this challenge prior to doing the live stream. Generally, I don't. But given that it's a Luke challenge, and he said, I think the tweet he said was like 7 out of 10 difficulty, I wanted to make sure that I had at least an understanding of how to go about it so that we don't spend, 3 hours trying to do this. So, because nobody wants to watch that. I certainly wouldn't want to. So, so let's talk about this, what we're going to build. Let's take a look at it. So very simple. I shouldn't say that. It's not simple. Very simple looking horizon chart, which is essentially an area chart. Everything's stacked on top of each other, and normalized to everything. So that's what that is. When we hover on it, we can see what the we get to see what that what the Arctic ice extent is for that, and for that day, which is pretty cool. So in the blog post that Luke put in, he talked about he gave a few resources of what horizon charts are. So let's go ahead and quickly take a look at those just so we kind of get a bearing. So Nathan Yao of the Flowing Data created this really nice example. Now Nathan does not use Tableau. He uses custom web applications to do all of his data viz. But this is a really nice good overview of what each is, of what a horizon chart is, right? So you've got this line chart, and then you can make it an area chart, and then you add color to that area chart, and then you band values within the area chart, right? So that's what these are, right? And then essentially what you do once you have all those banded, then you essentially normalize the bands back to 0. So then you just stack everything on top of within the same band information, right? So if you could imagine, the values go up to this, and then when you hit the top of that band, what would be up here gets brought back down to 0, and then you continue going up to that top level threshold. If there's anything above that, it goes over and over, and just like that. And then what you do is you use positive and negative color schemes, like he's done here, to do that. So that is a good idea. Like, again, when would you use that? When you've got a lot of data that's just line charts, but you're gonna have a lot of values that are above and below a baseline for that. So then we get into Tableau. What have we done in Tableau? Well, Luke also mentioned one of the great Tableau Viz authors from way back in Tableau's early days, Joe Mako, Tableau Zen Master. Some of his forum posts and forum answers are legendary. If you're not following and or check out Joe Mako's Tableau public profile, you should. It's pretty incredible. And these were done in the early days of Tableau, so pretty cool stuff. But here he's looking at unemployment rates by state over time, and showing difference from the average, right? So it's a normalized, we're kind of doing a comparison, and then we're normalizing that. Other examples in Tableau, Shine, Plethora, Tableau Viz, Iron Viz 2015 winner, created this about crime waves in the United States, which is really, really cool on a black background with colors that really pop out at you by different types, different crime types. And then more recently, we've got Mark Reed, Tableau Zen Master, Tableau Visionary, who did a very similar thing, right? And he walked through a very similar kind of setup from what Nathan did, only with Tableau specific language, right? And so he actually walks through a lot of these really great pictures, right? So this is kind of what I talked about, right? So the very first thing you got an area chart, then you're going to band that area chart into equal slices, and you're going to color those based on the values, and then what you're going to do is you flip the negatives to the positives, and then you bring everything down so that you stack everything within one original slice. So that's what we're going to do. So let's go ahead and hop in to Tableau here, and let's go back to our requirements. All right, petition so we've got dashboard, one sheet, normalize the Arctic ice to run between 0 and the maximum ice extent. Build a horizon chart with five levels, and then partition the data by decade, and then only show through the 80s through today. And I think that's a typo because our chart only shows the 90s. So we're going to go ahead and fudge this to see 90s as opposed to the 80s, because that's what the visual has. All right. And then on the x-axis, show data by day of decade, and then match the formatting of the horizon chart. Okay, so that's what we're going to do. So the first thing we need to do, I've already connected to the data source, and I'm going to go ahead and create a data source filter on year to bring in at least 1990. Click OK. Now that's taken care of. Don't have to worry about the rest. Worry about that the rest of the way that I go. All right. Now the next thing that I'm going to do here is I'm going to. There's a couple different ways that we can do this by decade. One, I could write a calculation. Two, I could do a group. What I'm going to do, I'm going to bin these this year here. So right click on year, create bins. I'm going to call this decade, and then the size of bin is going to be 10. Click OK. Let's take a look at what that looks like. 1990, 2000, 2010. Very good. We're good to go so far. All right. Now, the next thing we need to do is we need to figure out how to get each day of the decade in our view. Again, we could do a normalized, we could do a baseline date calculation. We could do a bunch of different things. The way that I'm going to do this, I'm going to put day of date on detail, day of date, make it continuous. And now you can see here, by building this out, I've got a mark for each day within the decade, and then it starts over. So I've got all my January 1s lined up, January 2, and so on and so forth. Now, in order to get that wavy continuous line, I need some sort of a continuous axis on here. And if you haven't figured it out yet, I'm going to do an index. And then I'm going to do this. I'm going to edit my table calculation. And I'm going to do this. And I'm going to do it for everything in the partition. However, I'm going to restart every decade, right? So I want number 1, right? So if we put, let's see here. And then from here, if I just throw this out here, I should start to see wavy lines, right? And it, for some reason, it says automatic mark type of shape, which is strange. I'm going to change that to a line, and there we go, right? And I'll change this to entire view, and there we've got our waves, right? So what we're doing here is we're just simply validating that we've got the right setup for our axis. All right. Now we're not going to end up using this. We're going to end up doing some other calculations and stuff, but this is a good way to get started here. All right. Okay. All right. So the very first thing we need to do is we need to figure out how to normalize this NH value. And we need to normalize it between 0 and 1. Right? And so if you're gonna normalize things, basically what you need to do is you need to take the generic formula to normalize between 0 and 1. The generic formula is, I'll bump this up so you can see it, is row value minus the overall min divided by the overall max minus the overall min. Right? That will bring everything back to between 0 and 1, right? Where it's 1 is where the row value minus the min equals the max. And if the row value is this overall minimum value, then it will be equal to 0, right? And then everything will be in between that. So that's what we're going to do. And the way that we're going to do that, so I'm going to get rid of this. The very first thing we need to do is we need to do the overall min. And that's just going to be fixed min in H, right? I'm going to build this out piece by piece because that's the way that's the way we do it. So just a curly bracket min in H. Now, if you've ever, if you're like, obviously this is a fixed level of detail calculation. When you don't have any dimensions that you want to fix it on, you just want to fix it on the entire data set, you don't actually need to write fixed or give it any dimensions. You can just write the curly brackets, and that will do that. So now we've got that. I'm going to do the same thing for overall max. And that's, again, just going to be curly bracket max in H. Just like that. Now, if I were to, just to make sure that we're doing things the right way, if I were to take this and put that there, I should see a straight line at whatever the minimum value is. And if I do this over here, I should see another straight line value at whatever the maximum is. Right? So that's working the way that that's the way it's working, and it's working quite nicely. All right, so the next thing we need to do here is, now we're ready to create the normalized value. And it's just going to be what I mentioned. Now, we do have to do a little bit more aggregating here just to make sure that it's happening right. So what I'm going to do is do the average, not a fixed average, just a regular average of the NH value minus the sum of overall min. And close this guy here. And then we need to do the sum of overall max minus the sum of overall min. All right, so we'll bump that up so we can see it, and then I'll drop this. So row level value, and I'm doing the this value is the same, right, as the overall max and min, but I'm just going to aggregate it just to make sure that we don't mess up anything later. So by doing it this way, this will be an aggregate calculation as opposed to a row level calculation. This will be an aggregate, and so I won't have to worry about doing sums whenever I write other calculations. So it's good to kind of keep that. All right, so we have normalized value. There we go. Click OK. All right, now let's go over here. Let's go over here and let's throw on the normalized value and let's see what happens. Now, if I've created this correctly, what you should see is the exact same shape. The shapes will be identical, but these values, right? These values on the axis are going to be between 0 and 1. Let's see if we did that. Perfect. Right? So we've got the exact same shape, but our value is normalized, right? Our axis is normalized. This is a really good. This normalized value is not used. Just it has a lot of applications. Sometimes whenever I'm creating KPIs, and I'm doing a measure name, measure value KPI sheet across the top of an executive dashboard or something like that, right? And I want to have, I've got the big bands right above, and then I want to show a spark line of each of those KPIs across time. But let's say the KPIs are of different orders of measurement, right? So we might have values, we might have integers, we might have floats, we might have percentages, those types of things. By normalizing all of the values to each individual KPI, you can get everything on the same scale, right? So as opposed to trying to create a different sheet for each KPI spark line, you can normalize all of your KPIs, KPI values, and then you just create a measure name, measure value spark line sheet that has a different partition has a different column for each KPI value. So that's kind of a little trick that I use. All right, so we'll go ahead and get rid of this because we know that this is working, right? And then we know that it's working because there's our 1, and it is the only one. Because we've normalized it, it is the only one because there is only one value that hits 1. That is the max, right? And we also know here's the 0, right? And then everything else is somewhere in between. Okay. So now what we need to do is if we go back to our examples here, we've done this part, right? What we need to do now, so we'll create let's do this. Let's create our area chart. Right? And what we need to do now is we need to figure out the bands. We need to basically slice each one horizontally at a at every 2 decimal places, right? So what you could do potentially, if we did normalized value, I don't know if it won't work because I was going to say we could create bins off of the normalized value at 0.2, and that would give us 0 to 0.2 to 0.4 to 0.6 to 0.8 to 0 or to 1. But because this is an aggregate calculation, Tableau can't do bins. So another trick for you, if you want to do a bin calculation, it has to be a row level non-aggregate value, right? So it can't be aggregated. It can't already be pre-aggregated. That's what I should say. Okay, but we could do something like this, right? We could say, you could create a calculation that says, you know, if the normalized value is less than less than or equal to 0.2, then it's level 1, and else if normalized value is less than or equal to 0.4, then 2, else if normalized value is less than or equal to 0.6, then 3, else if normalized value is less than or equal to 0.8, then 4, else 5, end. That's going to create a measure. We're going to throw that into, we're actually going to convert that to discrete. And the reason it won't allow me to go up into the dimensions is because I'm using a pre-aggregated calculation, and therefore we don't have the ability to manipulate that. But we can change it to discrete, and now when I change it on, when I throw this on color, let's see, that's not working the way that I wanted it to. Okay, so, but essentially you can imagine a slice at each partition, right? So basically, and that's why this is not working, right? Is because what I need to do now is I'm going to create separate values to create this, to slice everything up. So here's what we're going to do. First, we can get rid of this because I'm not going to use it. Let's keep our workbook clean today. What do you say? All right, create a calculated field. We're going to do normalize. We're going to do, this is the 0 to 0.2. And we'll say if normalized value is less than 0.2, then normalized value minus 0.2, else null. Right? So if the normalized value is less than 0.2, then what I want you to do is I want you to do the normalized value minus 0.2. Right? And remember, and why are we doing this? Well, because what we're doing is we're taking, if we look at this, we have the negative values, or the 0.2 values that are going down, right? So these are potentially going to be, because if it's 0, if the normalized value is 0, so this guy down here, right, is 0.0, we're going to do 0 minus 0.2, so it's going to end up below, right, the x-axis, and that's what we've got going on here. Okay? All right. So we'll click OK. We've got that. Now we just keep building on this, right? So now we've got 0.2 to 0.4. And that one is going to be if normalized value is less than 0.2, then negative 0.2, else if normalized value is less than 0.4, then normalized value minus 0.4, else null. And I'll move this over. And all right, so let's look at this. If the normalized value is -2, is less than 0.2, then drop it down to -2. So what we're doing, again, if we think about, if we go back to our if we go back to this, well, here, right? So what we want to do is we're saying, right? So this is the, right? So this is that first calculation that we did, essentially, right? We're putting it, we're moving it below that. Now what we're saying is, okay, now go down to 0.2, but then we also want you to additionally add on top of that. So that's how we're kind of stacking everything up. Okay. And then we'll do 0.4 to 0.6. Right? And again, you kind of start to see the pattern. If normalized value is less than 0.6, then 0.2, else if normalized value is less than 0.4, then null, else normalized value -4. 0.4. That would have been really weird. End. Okay? So, let's talk about this. Let's blow it up and talk about it, right? So let's start from the inside and work our way outside. If we'll go first. If the normalized value is less than 0.6, meaning we've already taken care of that in other calculations, right? That's what that's doing. That's just dropping it down to 0.2. Otherwise, for those greater than 0.6, no, yes. Let's see. If it's greater than 0.6, if it's great, right? So if it's less than 0.6, this is what we're going to do. No, this is not right. This is greater. This is that way, right? Yes. If it's greater than 0.6, we're going to drop it down to 0.2. If it's less than 0.4, we're going to null it out because we've already taken care of it right here in other calculations. But if it's greater than 0.4 and it's not less than 0.6, then we're going to take the normalized value minus 0.4. Okay? And then we'll do 0.6 to 0.8. That, and this is similarly going to be like the last one we did, which is if normalized value is greater than 0.8, then 0.2, else if normalized value is less than 0.6, then null, else normalized minus 0.6, end. And the last one is not a parameter. Got too quick on the feet here. Then what we've got here is, hey there, Rodrigo, how are you? Good to see you here. Thanks for joining in. Is going to be 0.8 minus 1. Or 0.8 to 1, right? And that's just going to be if the normalized value is greater than 1, then 0.2, else if normalized value is less than 0.8, then null, else normalized minus 0.8. Rodrigo says he's only here to be amazed. I appreciate that. Not sure how amazing I am, but I appreciate the sentiment. You only do standard stuff. That's cool. A lot of us only do standard stuff. It's good to break out of our shell, out of our routine every once in a while, and do some fun stuff. But I know what you're saying. So again, thank you for joining along. Appreciate it. All right. So again, let's what are we doing here? Let's look at this. If the normalized value is greater than 1, then we're going to drop it down to 0.2. Because again, that's how we're stacking everything. By dropping everything greater than, that's how we're gonna do that. If it's less than 0.1, right? Then we're gonna do this. So it's less than 0.1, okay? If it is less than 0.8, then do nothing, because we've already taken care of it in other calculations. Else, do the normalized value minus 0.8. All right. Click OK. All right. I think we're ready to finish this here. So we've got some weird stuff here. It's all right. We're going to do measure names. And we just need to do all of our ranges. Measure values. And there it is, right? Now, here's where things get tricky. I need to put measure names on color. All right, there we go. So we've got an area, stack chart. Things are looking weird right now. It's okay, we'll fix it. I'm missing 1. There we go. There we go. Excellent. All right, now things are looking okay, but we still have this dip here, right? So this is where things get interesting. So, are we ready for this? Let's show the header. Again, we went to, this is where we have to manipulate a few things. So, first, let's get our colors right. And let's see. Yeah, let's do that. Edit colors. And actually, let's go ahead and stack these the right way. So, I'm going to drag these around here to make them where they need to go. So just kind of we'll do 0.2 to 0.4, 0.6 to 0.4 to 0.6, and we'll move 0.8 to point there. Right? Okay. So here's where we have our bands now, right? And this may not end up being exactly correct. We may need to do some finagling. But what this is going to allow us to do is we can now go back to Luke's stuff and get us the... All right, so 0.8 to 0.1 is going to be this color. 0.6 to 0.8 is going to be this color. This is going to be white. Point 2 to 0.4 is this color. And that's going to be this color. There we go. Click apply and let's see what it looks like. Okay, so I do need to do some finagling with the stacking. So we'll do this. Do that. Yep, I think this is the way it is. All right, so the next thing, Tableau, area charts automatically get some opacity, which is nice. Okay, so there was that. Now, what we need to do is we need to figure out how we're going to flip these things to be on the same axis, right? So basically we need to figure out a way to get these here. Now, we could write some crazy calculations to do that. However, I'm going to take a little bit of an easier route. So I'm going to edit this axis. And by doing it this way, what I'm going to do is I'm going to do something that very rarely ever gets done. So if you think you know what that is, drop it in the chat. But I think you're going to be pretty interested by it. Okay, so the very first, we're going to do this axis. This is going to be our positive axis. So it's going to go to it's going to go from 0 to 0.2. Now I'm going to just duplicate this. And I'm going to show this header. This one is going to be negative 0.2 to 0. And now, when I make this, when I drag this over here and make this a dual axis, I'm not going to synchronize my axis. This is one of the very few times, one of the very few use cases that you do not synchronize your axis on a dual axis chart. But let's talk about this. Let's hide our axes. Let's hide our rows here, or hide our. There we go. Get rid of our null indicator, and there we have it. Right. So now, if we look at his example, we've got everything that is done. Right. Nice little refresh. There we go. And now, so there you have it. So that's how we did it. So now we just format this. We'll get rid of all of our lines. No grid lines, no zero lines. Let's see what else. Yep, we've still got that. Oh. Ooh. Okay, so if we look at this, let's show this again, show header. So Tableau gives us this little extra, when I do the index, the continuous axis, it gives us this little extra bit of, stuff here. And it actually ends at 3653. 3653, is that the max? Okay, so we'll do here, we'll do edit this axis, fixed, 0, 36, nope, 3663, is that what it was? Let's see. No, 3653. There we go. Now let's see. Yep, bumps up right against there. Maybe there's a couple of we'll do 5-5. We'll give. Yeah, I like that better. All right. So now we'll get rid of this. Now we can go here and get rid of our borders. We need our row dividers, but not our column dividers. Get rid of our index axis, get rid of our row labels, and there we have it. Now we just need to format our tooltip, which is the actual value in kilometer and square kilometers for the date. Okay, so I don't think I have that. I need to put the actual value in the tooltip. And that's the other good thing about what I mentioned about doing this in the doing these normalized values all the time, or doing these normalized values, is you can normalize the axis and it still has the same shape, but it can all be on the same axis, right? But now you can, in the tooltip, you can actually put what the actual value is instead of showing the that 0.2 to 0.4. They're not going to know what 0.791 is, negative 0.197 is, but they are going to know what the 6.19 cubic or square kilometers. So now we'll go back up here. We'll go sum of NH. Make it bold. Make it black. Km to a power of 2. And the date. Get rid of our command buttons, get rid of our selection, and there we have it. All right. Now, let's talk about what's interesting. Like, because we chose 0.4 to 0.6 as being a white band, it's really hard to know that there are actual marks there. But at the same time, maybe we're not necessarily concerned with those because they're the average. Yes, if you so Rodrigo just says if you use different colors, it'll look like a fire flame chart. Yes, and that is what as I mentioned at the top, when Shine Plethora from 2015 created this. Oh no, January 2019 is when he created it, but you can see that he used some really nice color palettes in this to do that. So cool stuff. All right, so back to this. So that really wraps up what we've done. Now we just throw it on a dashboard, give it a title, and give it everything. Good to go. So what did we talk about? Well, we learned about binning, right? We learned about how to normalize our values, and then we learned how to slice our area charts into equal bins, and then drop them to a normalized axis, which is really cool. So hopefully you found this interesting. Hopefully you found it informative. You learned something, and who knows? Maybe a horizon chart just might end up in your next business dashboard. Who knows? Like I said, check out the links that I sent or that I shared. Check out the links in Luke's post, and you can learn all about them, learn more about them. It's pretty cool. And that's what Work at Wednesday is all about. So, thank you so much. Hope you guys had a great time, learned a lot, and yeah, we'll see you next week. Go forth and viz.